My name is Paweł Kosiec, and today I would like to talk about building GraphQL API for Kubernetes resources. And before we will start, I would like to introduce myself. I'm a full-stack developer at SAP Labs Poland. I'm working on schema open source project, more on that later. And also I'm a co-organizer of Gopher Silesia meetup, which is intended for Go and cloud native people, right? Yeah. So let's move to the agenda. And at the beginning, I will give you more context about our use case. Then I will move to the API design description, and then I will cover caching, security, tracing, and also a little bit about future of our project. And last but not least, of course, summary. So let's start from context, right? So what I will say today is based on our experience while working on schema project. And what is schema? Schema is a flexible way to extend and to connect and extend your enterprise application in a cloud-native way. What does it mean actually? So one of the key, let's say, one of the selling points is application connector, which allows you to connect your enterprise application and extend it with microservices and Lambda functions. Also, there is a serverless engine. We have kubeless, or it can be based on Knative as well. We have service management, which is based on service catalog. You can consume services from cloud providers in very easy way. And also, we have built-in monitoring, tracing, and logging. And we also have Istio service mesh set up out of the box. So actually, schema is actually more than that, but those are the selling points. So basically, this is, let's say, Kubernetes with a set of extensions, right? And what does it mean? It means that we have many Kubernetes resources. So in our case, we wanted to enable users to manage their Kubernetes resources easier, right? And our solution for that was building an extendable, let's say, dashboard called Console UI. Of course, there is a Kubernetes dashboard, right, for managing resources via UI, but it's not extendable, right? So just for reference, this is how the console UI looks like. So this is the actual screenshot. You can see there are many tabs on the left side. So you can also manage some core resources like paths, but of course you also can see some service management related features. Of course, this is just a part. So let's how to build that. Let's start from sketching some diagram, right? So we want to have some UI, and we want to consume the Kubernetes API server. What option we have actually? First option is to use the Kubernetes API server directly, right? So this is how it would look like, and the problem number one is that we are actually, in this case, we are actually hitting the Kubernetes API server definitely too much. We need to remember that if we kill API server, then the whole cluster is down, right? So the second point is that actually on the UI side we have complex logic, right? We need to make multiple requests for a given view. We need to somehow merge the responses, do some other computations, because of course the Kubernetes API service is a simple CRUD API, right? So this is also not a great, let's say, point of this solution. And also, we are actually limited to the CRUD operations, right? Like I said before, this is how the Kubernetes API server, right, works. So if we would like to have another, let's say, some logic, right? Then we definitely would need to deploy a new service for that, right? So yeah, there is also option number 2, which is building an additional backend service for our UI, and this approach actually gives us an ability to implement caching, right, for read operation. Also, we can simplify the API for our UI, and the UI can be, let's say, some kind of dumb, right? The whole logic is on the backend side, right? Which should belong actually. So and also it's easy to extend the whole service with some our custom logic, not based on the Kubernetes resources management, right? And the last thing is that we actually have an ability to choose other architecture style than REST, right? So mostly because of the first and second point, we've picked option number 2, and I believe that in most cases it's better way to do so. So now let's move to the API design description. Of course, in the whole presentation title there is a huge spoiler, right? We did use GraphQL, of course, but just to give you some kind of description, well, what is it if you didn't use it, then I will just cover the topic very quickly. So what is actually GraphQL? GraphQL is a query language for our API, but it's also a complete server-side runtime. So it's actually ideal for using on UI side. I mean, including also mobile apps. And it can be built on top of REST API, so we can keep both, let's say, APIs alive. And there are multiple implementations of GraphQL, not only on server side, but also on client side, in most languages you will ever imagine, right? So basically, how it works, but how does it work? So the idea is quite simple, right? We need to define some GraphQL schema in a language agnostic schema definition language, and in this example here, we are specifying that the API server can that our API server, of course, can return a person, right, for a given ID. So as you can see, we are using types, and yeah, basically we are defining that this is read-only operation because this is what the type query means, right? And next, as an API customer, we just specify what we need in, for example, for given, let's say, scenario, right? For example, we want to, I don't know, display just ID and name of the person, right? We don't need age, for example, right? So we are defining this kind of query. This is the body of the request, right? And what we are getting is exactly the same shape of data we specified. And to actually return this kind of these pieces of information on the API side, we need to implement functions which are called resolvers. And in this case, we have resolver for person, right? So this is a simple function which actually returns the person, right? Person type for a given ID. And just to give you a quick glance, let's say, for some kind of comparison in those two approaches, REST and GraphQL, I've prepared a very quick example, and I wanted to, to have some kind of real-life scenario. So let's say we are utilizing GitHub API, right? Because GitHub in version number 3 still have actually REST API, right? In version number 4, there is a GraphQL API. It's still not complete, but they are moving slowly to GraphQL. And let's say in this example I will show here, we want to get details of some pull requests from Schema repository, right? So let's say we want metadata, some assignees, commits, comments, and reviews, but just just basic kind of information, which means, for example, ID and message of commits, and author names and body of comments, right? So firstly, we will use REST API, and to to do the whole stuff, we need to do actually 4 requests, right? Firstly, we need to query for details of pull requests. And as you can see, actually there's a lot of information we don't want to use anywhere, right? So this is called actually overfetching, right? So we have too many data here. Also, there is an underfetching visible, which means we need to do additional requests, HTTP requests to get the whole data, right? And look at the computation time actually for every of those requests. It's summing up those 4 requests is actually the whole, let's say, our query, right? Takes about 2 seconds, right? It's quite huge time, right? So let's see how it would look like in the GraphQL approach. So we have a single endpoint here, and just one query defined in the body of the request. So as you can see here, you can see actually the types of the in the IDE. You can see types of the whole types description actually, because this is what IDE does. It does introspection query, the API. But as you can see here, this is just a single query to get all the data we need, right? So, of course, we need to specify that we want, I don't know, just message or an ID, right, of commit, etc. And look at the computation time. It's really, it's much less, right, than what we had in REST API. So, as you can see, in this case, GraphQL rocks, right? So, what are the benefits of the GraphQL? First one is that there is a strong type schema. Also, there is no underfetching and overfetching I've mentioned before. And we can actually make our database queries more efficient in GraphQL. Also, there is a very easy let's say to spin up the support for real-time data. And there is also auto-generated API documentation. So if you just write the schema in the schema definition language, if you comment all types and queries and all other GraphQL operations, then it will be just, you know, out of the box, auto-generated. And actually, that's why we use the GraphQL, right? Of course, you need to remember that GraphQL is not a silver bullet, right? It's different approach than REST, and of course, it has its own challenges. Let's say, for example, in GraphQL we don't version API, right? We have something called API evolution, because this is the approach that GraphQL authors, let's say, wanted to implement, right? So we shouldn't do breaking changes, and we need to, you know, handle that, right? But still, I think the benefits are huge, at least in our case, right? So if you want to write some GraphQL server in Go, then there are plenty of solutions. But to be honest, we took time to investigate which of the tools are the best. And to be honest, there is only one option regarding Go. It's GQL and it's a schema first solution, which means you need to define the GraphQL schema, and then you can generate the whole Go boilerplate code, right? So you are just you can just focus on the business logic in your resolvers. And also, GQL supports actually most of the features which are in GraphQL, right? So, for example, the whole subscriptions, which is a real-time data operation. There is file upload, also data loading, etc., etc. So now let's move to the caching. And this is actually more focused on Kubernetes resources. So in this section, actually, I would like to cover not only caching Kubernetes resources, but also querying, and I will talk also about pagination. So let's start from caching Kubernetes resources. And in order to cache them properly, we need something called shared informer. And what is actually shared informer? It's actually a part of client Go package from Kubernetes, and it basically lists, let's say, observed resources on start, and then watches for updates. It maintains a locally, let's say, eventually consistent cache, and also it has an ability to register multiple event handlers, for example, add, update, delete events, and it's really helpful for example, subscriptions I mentioned before in GraphQL. And actually, informers are widely used in Kubernetes controllers. So if you wrote one, for example, in a kube builder or somewhere, I mean, while using other solution, you probably use the shared informer. So benefits are really, really huge of the shared informer because there are as little Kubernetes API calls as possible. So there is just one list request for the Kubernetes API server, and then the informer establishes one single connection to watch for updates. And actually, you can set up the whole cache store in a few lines of code. And you can actually synchronize resources of any kind. Previously, you would need to generate this API, but right now you can use dynamic shared informer. Okay, so right now you can use dynamic shared informer, which actually you can provide any kind of resource you want to, right? You want to watch, and also that I mentioned before, it's really, let's say, cheap, and. I also mentioned before that the event handlers are really useful for subscriptions in GraphQL. So now let's move to querying Kubernetes resources. And before we would move to the querying on our cache store, I would like to start with checking out what are the features available from Kubernetes API directory, right? So, for example, we need to forget about our cache, and we want to do some queries to Kubernetes API server directly. And we have actually two options. We can filter resources by label selectors and field selectors. But field selectors actually are very limited because the support vary between Kubernetes resource types. And the problem is also that it's expensive, right? So do we have an alternative? Of course we have, because we can do queries on our cache store. So for that we will need indexer, and indexer is also a part of the shared index informer, and it allows you to index objects by using keys and by using index name and key. And it uses thread-safe store to store object and their keys, and we can actually specify multiple indexer functions, which is really useful. So benefits are that we can actually query every Kubernetes resource by any property or combination of properties, because it depends on how we actually define the indexer index functions, right? And there are no limits on fields, and the best part is that all is done in the on the in-memory cache store. So, for example, we can get a service class resource by external name field from spec, right? Or we can, for example, list all pods with the ready face in a given namespace by defining namespace /face index, for example. So you're probably wondering what's under the hood. To just give you an overview how it works, you can see there is a Kubernetes API server and client Go package, and we have first, let's say, item, which is a reflector, which lists and watches for updates, right? For updates on the Kubernetes API server. And if it sees some change, then it will add an object to a delta FIFO queue. And Informer pops out this object from the queue, and then dispatches events to event handlers we define, right? This is our logic, right? Defined in event handlers. And also Informer adds object to indexer, which puts it to thread safe store along with the indexer name and keys. And if you want to see how it is done, because there's to actually, I didn't want to to just do some deep dive here on the presentation, but I've prepared some examples how to use the Informer, how to use the indexer, because to be honest, for example, dynamic index Informer is not well documented right now on the Kubernetes docs website. So that's why you can see some additional sites how to set it up and use it. All right. Now it's time for pagination, and again, let's take a look what Kubernetes API server offers at the beginning, right? So we have a feature called Kubernetes API chunking, and this is actually an ability to break a single large collection into smaller pieces, right? And it's based on two parameters: limit and continue. It's when you use it, then it will return a continue token to just continue the pagination, going through those objects. And this is feature available in Kubernetes 1.9 and newer. So, for example, if you want to get first 500 pods, then we will do some get requests like this with limit parameter, and in the response we will get in metadata of the pods list continue token. So now when you just do additional requests with the continue token, then we will get another 500 pods, right? And another continue token. And with the new continue token, the result will be that we will get additional 27 pods. But the continue token is empty, which means we finished the whole pagination, right? What about pagination on the shared Informer store? Unfortunately, you need to implement it on your own, right? Because it's kind of obvious, but still, I think it could be worth to do so, because we will not use Kubernetes API server directly, right? And just for reference, how I believe the best or one of the best implementation of pagination in GraphQL servers should look like. I believe that we should get actually defined two parameters. First and after. Page cursor is actually a string, and we have some we need to return for some query a page, right, where our data, which is a collection of items, and also we have page info. And page info contains start cursor, end cursor, and boolean for if it has another page, right? And I think the total count also is very handy to have. So this is I think the implementation we should take a look at while implementing it, right? In the while developing GraphQL server. So now it's time for talking about security, and and how we actually secure our GraphQL service. So what we wanted to achieve is to limit actually the access to different queries and mutations and subscriptions to based on the resource, right? So for example, we had pods query, right? And we wanted to limit it to per the operation, right? And our execution was that actually we used Kubernetes role-based access control, and we implemented HTTP authentication middleware before the GraphQL server itself, and also we use GraphQL directives, which I cover later. So the whole API request flow would look like that user just sends a request to our service, which is called console backend service, and then the token is validated. So here we have actually the HTTP authentication middleware here, and now when we have user info, we just putting it in the context of this request, and then in GraphQL directive, which is a GraphQL middleware, actually we are doing subject access review. And when we got if the user can or cannot access this kind of resource in given namespace, then we return a response. So the directive is, as I mentioned before, is let's say some kind of GraphQL middleware. When if you have pods query here, then for example, let's say user just queries pods, right? So it will use this query, but before executing resolver for this query, actually the whole directive will be fired, because directive this is an additional function, right? And if this function will return an error, then the resolver won't be executed at all, right? If not, of course, then the resolver will be executed as usual. So we defined has access directive, where we specify the attributes needed to perform the subject access review. Actually, we needed to specify which rules are valid for this query, right? So this query, to run this query for pods, user would need to have an access to pods in, of course, core API, right, of Kubernetes, and the verb is specified as list. And also we have additional parameters, parameter namespace arc, which means that this is the argument for namespace, right? We need to see what user is actually querying, and check if the user has access to the namespace, right? To pods in given namespace. And just to you need to also define our role, right? For pods, for example, for listing pods, and then you can bind this role to your user or service account or group of users, right? Now it's time to move to tracing. And regarding tracing, just to give you a context, we are using Jaeger as a backend solution for tracing, and GQLGen supports open tracing. So actually, the whole setup was very, very easy. So we needed to initialize the built-in tracer, and we needed to use our own trace collector, and actually that's it. So let's take a look at the example. So here we are doing a query for cluster service class resource, And then we have also some related resources like service plans, cluster service plans, service instances, and cluster docs topic, and also assets. So as you can see on the orange color highlights the different Kubernetes resources. And it means that actually in a REST approach, we would need to do actually five requests, right? So at the result, after navigating to the Jaeger UI, we can see actually what are the times of the execution of the resolvers, for example, and the arrows highlight actually the different resolvers fired, right? So there are different Kubernetes resources. As you can see, it's really easy to just find some problem, right? For example, and of course you can look at the times. They are really small because of using caching. All right, so actually, what's next to our component? To be honest, it's because this is right now. This is a single server, right? This is a single project, single component, and the problem is that it's getting bigger and bigger because we need to write some GraphQL logic, right, for different Kubernetes resources we want to support in our UI, and that's why I think that we will need to eventually split it to a few microservices, right? So, but this is the question how we should execute it because to be honest, we have a few options available. And I believe that the only good option regarding GraphQL is to compose multiple GraphQL schemas into single endpoint. It's also, you probably heard about schema stitching if you are familiar with GraphQL, or maybe schema federation. This is actually the more or less the same concept. So how it would look like? Actually, we could have a gateway, GraphQL Gateway, which exposes a single GraphQL endpoint, and the gateway could aggregate the GraphQL schemas from multiple GraphQL microservices, right? And at the result, the user actually sees the same schema as before, right? While actually, let's say, doing some requests to a single service. So the whole gateway shouldn't be actually written. Of course, it should be actually generated, or actually it shouldn't need any setup, right? So there is one option how to do it. There is a Apollo Federation, and it's actually. It's implementing the concept, right? So, but problem is that it is based on some custom annotations on the GraphQL schema, which is not really nice. And also, it's worth to mention that this is a, let's say, a new let's say evolution. This is an evolution of the schema stitching from Apollo as well. But what is still missing? We would like to have Go implementation, to be honest, because our rule in Kima is to have all components in cluster, to have the components written in Go. And also there is support for the Apollo Federation missing in GQL Gen. And another problem I see is that we would need to specify some custom annotations of the GraphQL schemas. But there is also another option, which is called Nautilus Gateway, and it actually does the same thing without any custom, annotations in GraphQL schema, and you don't need to, rebuild it or something like that. It just works out of the box. So you just need to specify where are the microservices, and Yeah, actually, the whole gateway will be up and ready for doing some requests, right? And it's written in Go, but unfortunately, it's in a very early stage. As you can see, this is version 0014, so it's quite, you know, it's a rather beginning, right, of this project. So it's time to summarize the talk. I think that the GraphQL is really great for designing some APIs, especially for UI and mobile apps. Also, I would recommend to use GQLGen if you want to, you know, write GraphQL server in Go. And if you want to cache some Kubernetes resources, then I think it's great to have to use informers and indexers as shown before. And if you want to use GraphQL and secure it somehow in Kubernetes cluster, I think using directives is the only way actually to do so, or to do it right. And you can, of course, utilize RBAC from Kubernetes. And the last thing is that I think if you want to split some GraphQL service to multiple microservices, I think the only option is to have still preserve one single endpoint for user, GraphQL endpoint, and merge multiple GraphQL schemas. So that's actually it. Thank you.
How many instances of your server you have on the cluster?
To be honest, actually we don't maintain let's say production cluster, because Kima is on let's say this is a project you just pick, right, and then you can build some solution on top of that. So we don't, you know, we don't host any, let's say, instances, right? Well, yeah.
Okay, and second one, so actually this console, it's an extended version of this Kubernetes dashboard, or it can do some more fancy things?
Actually, console is let's say it's totally, let's say, written from a scratch, right? So this is a UI written from a scratch, but it actually utilizes some kind of micro front-end concept, so you can actually extend it. So for example, if you just pick the schema, right, and you want to use it, and somehow you want to extend the whole dashboard, it is of course possible. So yeah. This is the thing. Let's say this is the difference, right, between Kubernetes dashboard and console.